Hello, algebra friends. I'm going to play around with 2 points to make a linear function, and this time I'm going to do it with technology. So I'm going to use those 2 points there with Desmos calculator. And so one way to do it would be to add the points with a table. So I have -2, 1 was 1 point, and I have 6, -4 for the other points. Check I got those right. Yeah, looks good. So once I have them there, I can then ask Desmos to create a linear model for me. To do that, I make a note that this table, the y's are called y1s, and I say y1, and then I use the tilde to say make an approximation or model, and I want something that looks like mx. Again, the table has x1, so I have to put an x1 in there, and then plus b. And then it'll attempt to find the best line through the 2 points that I started with. And notice the r squared and the r value, they're pretty darn big. R equals -1 because it slopes down, it's got a negative slope, a negative rate of change. R squared is exactly 1 because, well, -1 times -1 is 1. Here it tells me the slope is -0.625. Can I blow that up in Desmos? A little bit. And the y-intercept is 0.25. Now, the downside of using technology is it's going to give you decimal approximations of the answers, and I think Desmos typically only gives 3 decimal places. So if you're looking for exact values, this doesn't quite get it. You would somehow have to turn those approximations into fractions, which can be tricky if you only have 3 decimal places. So this isn't a guaranteed way to come up with the answer, but it is a way that you can check to see if you have the right linear function. So according to Desmos, my linear function would be f of x equals -0.625 x minus 0.25. So I'm going to type that in and see what the system thinks. It's looking for a linear function, right? So I have to type f of x for a function equals -0.625 times x. Or you could just write x, it'll accept that too. And then minus 0.25. Occasionally, in problems like this, it wants a fraction, not decimals, and it might give you a warning, hey, decimals aren't okay. If this matches the exact fraction, you're good. If it's not close enough, then you'll probably get marked wrong here. So I'm going to submit it just to see what happens. Ooh, it likes that one. But it's not always going to work out that nice. Let's do one more just for fun. This one has 6 8s and 3 -8. Let's see what that looks like. So 6 8s and 3 -8s. And here, did I get those right? 6 8, 3 -8. Yeah, not too bad. 5.33333. A lot of us have seen the 0.3333 before. That's 1/3, so 5 1/3. And then -24. Well, not too bad. Let's try another one for fun. Jump to answer. I know. 16/3. 3 goes into 16 5 times with 1 left over. So there's my 5 1/3 for the slope, -24. Let's try a similar one. One more just for fun. 3 3, -8 9. All right. 3 3, -8 9. And this one's a little bit messier. So I'd have to figure out what is 0.545455. Is that rounded or should that be a 4? And then here I have 4 6 3 6 3 6. Which numbers are those? So this one's a bit trickier. You'd have to play around with these numbers here with the slope and y-intercept to figure out which fractions these decimals represent. And I'm going to leave that for you to figure out. It is kind of fun to change decimals into fractions. These are likely repeating. I doubt they terminate there and there. As a matter of fact, looking at these numbers, I know they don't. So, fun with technology. Enjoy.